Okay, here we go. Implicit differentiation. So far, you guys have taken derivatives with one variable, right? But what if you happen, so this is what we've done so far, right? We can take derivatives of those, pretty basic. But what happens if you have something ugly, like this? Right?
Depends on the.
Yeah, he's on the wire.
Yeah.
Okay. So this is just an illustration as to why we have implicit differentiation. Sometimes the variables get kind of nasty messy. You know, the graph of this one, and it looks something like that. Okay. That's what that graph looks like. Did you know?
Let's see if I can actually.
Okay. So here's how it works. I'm going to use an example to illustrate implicit differentiation. Whoa, that's not an N. Okay, what is the slope of the tangent line? 2x squared plus y squared equals 1 at 3/5, 4/5. Notice you're given an x and a y. We've been working with just an x value. Now you have to have an x and a y. Does anybody know what that shape is? It's a circle with radius 1. Yep. Okay, so that's what that looks like. We're looking for the tangent line. Somewhere in here. Okay. So we need the derivative of that function. Okay, what's the derivative of x squared with respect to x? 2x. What's the derivative of y squared? Okay, now it's a derivative of y with respect to x, so we actually have to label it now. dy dx. Okay, this one is x with respect to x, so we just leave it as is. But that one is the derivative of y with respect to x. What's the derivative of 1? 0. Now we have to solve for dy dx. Okay. You can plug the numbers in now, but I'm going to show it to you without doing that yet. All right, this is solving algebra equation. We want this to be alone, so we're going to subtract the 2x. And then divide by 2y. Okay, so we're isolating this guy right here. Negative x over y. That's the derivative. Okay. Now plug your values in. Remember that notation? dy dx evaluated at 3/4, 4/5.
Oh,
We haven't seen it for a few days probably, but there's the slope of that tangent line. Okay. So there's not a whole lot of new stuff. It's just that one little chunk right there. Okay, that's the new chunk. You good?
Let's do the top one.
The top one?
Yeah. Can't somebody that talks to them.
Okay. Well, let's do the top one. No, I was going to show you this one anyways. You will run into one of these on the AP test. I guarantee it. And it's probably going to be a particle motion problem. Free response. Best to know how to do it.
You can show us slow field.
This year we're going to get to slope fields. Yes. What is the derivative of that function? Well, equation is what it is. It's not a function. Okay. What's the derivative of y to the fourth? Okay, you took the derivative of y with respect to x, so label it dy dx. It's a product. It's a product rule. So 1 times y plus x times 1. Missing something. dy dx. Because that 1 was a y. You took the derivative of y with respect to x, so label it. And then the right side is easy because it's x's. All right. Solve for, I'm going to take you through solving for dy dx. Right? First thing I'm going to do is move the y. So I get now I can factor a dy dx out because it's in both terms. So I end up with, what is so funny? Ben, stop it. Not all women like flirting with you.
Just not say a word and get mad. That's what I said. Watch. I'm not going to say anything for the rest of the class, and he's not going to do that. And then here you go.
I'm not mad at you, and I didn't yell at you. Okay, now we can divide by. Yeah, I'm pretty good at that. All I had to do is say, Ben, you just got an F for not talking, and he would probably say something.
All right, there's dy dx. Yep, great, grand, and wonderful. Plug 1 in. That's what I got.
So you always put dy dx?
Wouldn't it be 2/5?
Pretty sure it's 1/5. 3 minus 1 minus 1 is 1. And here's your equation, right? It's the 0.11 and the slope of 1/5.
So you take the y value?
The y value goes here, the x goes here, yes.
Wait, x minus 1 without that?
Uh-huh. I just want to show you another way to write it. Okay, this is not my preferred notation, but it is in the book, so you're probably going to want to know how to do it. Okay. What's the derivative of e to the x minus y? So we copy the outside, or sorry, derivative of the outside, copy inside. Now the derivative of the inside. Okay, normally we would write 1 dy dx, right? But another way to write that is y prime. 1 times y prime.
1 times y prime?
Yeah, because it's the derivative of a y, which is 1 times dy dx. But we can write y prime there. Okay, and then this one over here, derivative of 2x squared with respect to x, 4x, minus 2y, y prime. Instead of writing dy dx, you can write y prime there. Okay. And then you can solve for y prime if you want to. So just another way to write it. I prefer dy dx, but it's because it's more obvious where the derivative is. Yes?
I have a question from the last one. When we did,
The last one?
circle.
Yes.
No, it was the waiter, jellyfish second. When you got 4y cubed with dy over dx, times y plus x with dy dx, how did you get from that to 4y cubed plus x?
Here to here?
Yeah. No, from the first, the one right above that. Yeah, from that to the.
I subtracted that y out on both sides. Alrighty. Let me give you the work. We'll let you off. And if you're good enough, I'll show you a video at the end of class.
310 or 311?
This is 310. Your test is next Thursday. As I look at my calendar.
That's all?
That's your homework.
Just wait till we get in.